Hi everybody. I'm going to do chapter 11, problem number 29. Basically, it has this kind of complicated circuit and wants us to find the equation for the charge on the capacitors. To, to solve these problems, we need to simplify this circuit into a more familiar circuit with a single voltage source, a single resistor, and a single capacitor. So first step to do here, we will need to combine these into one equivalent resistor. So we'll call that Req is equal to 5.6, and again I'm not going to use the K for right now because they're all the same, plus 1 over 47 plus 1 over 39. It gives us 26.9 kilo ohms. So that's all taken care of. Now we need to find an equivalent capacitance. If we remember from chapter 10 that each of these capacitors in parallel will charge to the source voltage. So both of these will have the same charge, so we can just add those together. So the CEQ is equal to 4.7 plus 2.2, which gives us a equivalent of 6.9 microfarads. Oop, that looks really bad. Sorry. Microfarads. So now we can take both of these and draw an equivalent circuit that's a little more familiar and a little easier to recognize. There, 6.9 microfarads. We have this resistor here, which is our Req, which is 26.9 kilo ohms. And our source voltage stays the same because we haven't done anything with that yet. That's 45 volts. Now, we know that the equation for voltage on a capacitor is equal to VC is equal to your source voltage multiplied by 1 minus e to the power of negative t over RC. RC, if you'll remember from my previous video, RC is equal to tau, which is also known as a time constant. So our RC is equal to 26.9 times 10 to the 3 multiplied by 6.9 times 10 to the minus 6. Basically gives us 0.185, and that's in seconds. Okay, so now we can take this number here and plug it into this equation, and also plug 45 into that equation. 45 times 1 minus e to the negative t over 0.185. The second part of this, that's the first part of the problem. The second part of the problem asks us to determine after one time constant what is, we had to compare that to a chart or a graph of some sort. So I went online and I found a chart. I'm going to put the link up here. For one time constant, basically you multiply your source voltage by 63.2%. So from here we know that 45 times 0.632 should equal what we put in here for one time constant. So when we put in one time constant, remember that one time constant is equal to 1 times your tau. So here 45 times 1 minus e to the negative your time constant over your time constant, so it's basically -1. We wind up with somewhere around 28.4 volts. And when you multiply 45 by 6.32, you wind up with 28.4. So it's just to show you that they match up. I'm going to try to put in a few more videos today, but if you have any specific questions, just let me know.